This question is called meeting probability, and it says two bankers each arrive at the station at some random time between 5 a.m. and 6 a.m. Arrival time for each banker is uniformly distributed. They stay exactly 5 minutes and then leave. What is the probability that they will meet on a given day? So some key terms here are that it's some random time and the fact that it's uniformly distributed. So like the probability of any given time is equal throughout that whole 1 hour span. And so we're going to create two random variables, one called x, one called y. A random variable is basically if you have like some outcome. Let's say the banker arrives at 5:05 a.m. A random variable just basically maps an outcome, which is like some series of words, to some number. I'm going to say our random variables is number of min after 5 a.m. that banker 1 arrives, and then y is the same thing but for banker 2. So I'll just like put it in quotes, but then write banker 2 here instead. So basically if we have the outcome banker 1 arrives at 5:13, right? That's in the outcome space, for example. And any time to occur in the outcome space is equally probable. So if we have this outcome, what our random variable here will do is x of this outcome will map to 13, because that's the number of minutes after 5 a.m. that they arrived. Okay, cool. So we want the gap between these random variables to be at less than 5. Less than or equal to 5. Because if banker 1 arrives at 5:10, then banker 2 can arrive between 5:05 and 5:15 at any time, because then at some point they'll overlap, even for a second, right? So we're going to say we're trying to find this. X minus y is less than 5. And this is like their distance. When you put absolute value, it means like if we're not have any negatives. So it'll just be this. And okay, cool. Now we're going to get rid of the absolute value sign by saying x minus y, right, could be less than or equal to 5, or x minus y could be less than or equal to negative 5. Okay, and then we're going to solve for y and for both sides. So we're going to say y, move that over, move this over, so x minus 5. So y is greater than or equal to x minus 5. Right. Okay, that one's supposed to be greater than or equal to. Other one's less than or equal to. Then you get y is less than or equal to. So you get y is less than or equal to x plus 5. Okay. Then you can plot this here. And this is 60, 60, 0. We can even shut it off this way as well. Okay. And then we can say this is 5. It's not the scale, but we're saying this is 5 and this is 5. Or right here and right here. And we're going to say this top line, right, we're going to put it in blue. So x plus 5 will go from here to there. This one we'll put in red. It'll go from here to there. When you fill in the gap, like fill in the region that this is supposed to be filling in, so as in like from here to here, for this one, for the blue one, it's everything below the blue line, and here is everything above the red line, so that means that's just this region basically. It'll be right here. So our answer is just this green region. That's our final answer. We're going to solve that final answer by noticing, and here it goes to 55, and here goes to 55. Basically, how you solve this is you're gonna solve for these triangles here, and subtract that from the overall square. So each triangle has side length 55, right? So you have 1 minus 55 times 55, and then it's going to be 1/2 base times height, right? And there's 2 of them, over 60 times 60, and that gets you this and this cancel, and you get 55 squared divided by 60 squared. Oops, that's not good. Okay, so you get 55 squared, which is 3025, over 60 squared, which is 3625. Yeah, divided by 25 gets you 144. 3025 divided by 25 gets you 121. So 144 over 144 minus 121 over 144 gets you 23 over 144, and that is the final answer. Random variables, set up the inequality properly, find the region, and that region is your answer. So yeah, that's the answer.